Welcome to this particular class, and this class is focused on designing a mask aligner. Now, what we have learned in the previous class is what is photolithography, right, and we have seen I think MJB4 operation of MJB4 mask aligner using the video that we had. And I am sure that you now know how the photolithography works, what are the positive photoresist, what are negative photoresist, what are bright field mask, what are dark field mask, how to align the wafer, right. Now, to align the wafer, mask aligner, right, and to expose the wafer, UV source, right. So, the cost of this system right now is close to like 50 lakh, and we have MEMS based sensors or design or technology related course in lot of universities, isn't it? We learn it, right, we learn it through books, but not all of us are having a setup within our university that we can go and see whatever we study in the book, how it looks like, right. And to bridge that gap, we need to develop a technology so that every university can adopt a system which is at lower cost. So, here in this particular lecture, I will be telling you something related to what I am doing in my laboratory, and this is also a part of this lecture because mask aligner or photolithography is an integral part of any MEMS based sensor. Now, what we are doing, right, we want to reduce the cost of the mask aligner, traditional mask aligner, to a value that most of the universities, most of the colleges can afford, right. If we see that okay, photolithography processes, you take the wafer, how wafer looks like, you can buy a wafer, it is like 1700 rupees, close to 2000 rupees. Now, once you have the wafer, right, what you will do with that? If you do not want to buy wafer, you can buy a glass slide, that also is fine, right. What is a photolithography step? Photolithography steps are: first you clean the substrate, second coat the primer. So, you need a small spin coater. There are varieties of spin coater available in market, at lower price you can get one. Spin coat photoresist, first we can spin coat primer or we can spin coat photoresist. After spin coating photoresist, we have to pre-bake. You can buy a hot plate, there should be hot plate in any chemistry lab, in biology labs. You put the wafer. So, again you have to perform all this thing in a yellow room, small room which is required to avoid the UV light, so that the photoresist will not get exposed to UV before we actually align the substrate coated with photoresist. So, what we require, after we spin coat photoresist, then you have to use a mask and load the mask on the mask aligner and expose it. Then you have to have developer small wet etchant and then etching the if you have a metal, you have to etch the metal, right. Now, you know the steps. So, how about we developed our own mask aligner and at a very reduced cost, and that can perform a photolithography step to get you a design, at least a simple design like a heater. Then you can connect that with the theory and probably understand how the photolithography system works. So, that is the idea behind developing a mask aligner within my laboratory. Now, when I will be teaching you this mask aligner steps, you will also know and learn that you can also do the same thing in your university. Try, take it as a project and try it, right. We should start finding an alternative solutions if we cannot afford a particular technology, right. Develop your own technology, right. We have to start developing things here in our country. It is a high time we use the knowledge that we have and put it together to develop technologies that are cheaper, that are affordable, that can go to the market, that can go to the universities, and all of us can get a better exposure to the education that we really deserve, right. Having said that, I am not telling that we are not getting enough exposure, right. All of us, all teachers and the management are trying best. I am sure we are trying best to our abilities to help you out to understand the technology as much as we can help you, but the lacking, the gap that lies is to show you the technology. If I talk about mobile is this, mobile can do this, mobile can send SMS, mobile can we can access lot of social network on mobile, we can talk on mobile, and we can see videos on mobile, but I do not show you the mobile. Then, but what if I just show you a simple mobile? Okay, this is a mobile, this is how it operates, this is a button, right, this is how you can use it. It is easier, no? That is the idea, that show whatever we are talking in theory in actual scenario. So, with that particular focus, with that particular idea, this today's lecture is framed. So, the name of the slide is mask aligner. So, if you see the slide, if you see the screen, we will be talking about mask aligner today, and mask aligner is used for photolithography. So, you have to see a slide, and the photolithography, photoresist is spin coated on clean wafer, we know it. The coated wafer is soft baked at 90°, we know it. Soft baked wafer is aligned to the mask and is exposed to the light source, UV light, right, to print the desired pattern on the wafer. The wafer is aligned to the mask in a mask aligner and exposed after that, right. So, what is alignment? So, let me just quickly tell you. Okay. Let us say you have we need a pattern which is like this. In the final wafer, this is what we need. Okay, this is our final wafer. So, we have done photolithography with a mask. Our first mask has, let us say, this pattern, and with the help of this first mask, we have used photolithography to design to get this pattern on the wafer, right. Now, this mask should have some alignment mark. What is the role of this alignment mark? So, you understand, right, we have first mask with this pattern and there are alignment marks, right, this is mask 1. So, our second mask, mask 2, would have this pattern, this is our mask 2, right. Now, I have to align this wafer, I have to align when I have to again perform photolithography with mask 2 such that I can have this kind of design next to my arrow. So, when I am going to align this mask, my wafer with mask 2, right, with mask 2, I have to load the wafer, I have to load the wafer, and the wafer is already having this pattern, right. Now, this alignment mark here and alignment mark here should align properly. So, if I have my alignment mark on my wafer looks like this and my alignment mark on my mask looks like this should align it. So, that if I see it, it looks like the mark of the mask is exactly in the mark of the wafer. With this alignment mark, we can align the pattern in the mask. If the alignment is not proper, then this can overlap, right. If the alignment is not proper, the wafer design, the design of the wafer can overlap this, and we will not get what we desire, will not get what we want, right. So, it is very important how to align this thing. For that we require a mask aligner. So, this is just two mask process, right. Mask 1 we form the pattern, mask 2 we form another pattern, right. Mask 2 was, if I remove this, mask 2 was another pattern, using mask 1 and mask 2 we want to have this pattern. So, the alignment mark role is very important. Another point you have to remember is always the alignment of the second mask is smaller than the first mask. If my mask 1 has a alignment mark, right, my mask 2 should be, the alignment mark of my mask 2 should be smaller than my alignment mark of my mask 1. That is very important to remember, alright. It is very important. So, remember these things. Same way, alignment mark for my mask 3 should be smaller than alignment mark of my mask 2. Alignment mark of my mask 4 should be smaller than alignment mark of my mask 3. Okay. This is how we can perfectly align the wafer and mask. Now, the wafer is aligned to the mask in a mask aligner and exposed. The exposed sample is developed and hard baked, right, and finally we perform the etching. So, this is the photolithography, we know it. How the mask aligner looks like, right. So, we see this is a mask aligner, we have it in Center for Nanoscience and Engineering at IISc, and this is EVG 620. So, this is a mask aligner. You can see here in the display, you can see how the wafer looks like, what the pattern on the wafer looks like. This is the exposure unit, right. This is the exposure unit. This is where your UV lamp is kept. UV lamp is kept, right. We require UV light to follow. This is a joystick to move X, Y, the wafer in X and Y. There is a theta direction for moving the wafer in theta. So, X, Y, theta, right, and of course, this is a mask aligner which is close to, as far as I understand, about 80-90 lakh. Some mask aligners are even like 1.5 crores, some are 2 crores, right, depending on the mask aligner. So, the point is, mask aligner is used to align the wafer to the mask and expose the coated wafer, right, coated with what? Photoresist. 3 degrees of freedom we get always X, Y and theta, right. If we want to align the mask, so you have to move the mask either in X, Y or theta, or you move your wafer in X, Y or theta. So, you have two options, either you move the mask or you move the wafer. I would prefer to move the wafer. You hold the mask, move the wafer either in X direction, Y direction or in a theta direction angle. Now, next one is, if you see the screen, the alignment marks on the wafer is aligned to the marks on the mask prior to the wafer, right. What is that? The alignment marks on wafer is aligned to the marks on mask prior to the wafer. So, that is what we have taken an example, that the alignment mark of mask 2 should be smaller than alignment mark of mask 1. In semi automated system, alignment is done manually, but in advanced automated system, automatic pattern recognition is used to alignment used in alignment system. Normally alignment process requires at least 2 sets of alignment marks opposite sides of the wafer. What does that mean? If I have the alignment mark, right, whatever the pattern here is, I require at least 2 alignment mark on the wafer. Now this does not mean that every time I had to draw a plus, I do not, whatever the pattern is, does not matter here, my alignment mark can be a plus, can be a triangle, can be a circle, can be any design, right. I just want to make sure that the mask 2 when I make the if I use a circle here, I am using a circle here, right. This circle when I align it with this one, this should be within it. This is mask 1, mask 2. So, alignment mark of mask 2 should be less than alignment mark of mask 1, should be smaller than alignment mark of mask 1. That is very important to remember. Okay. So, normally alignment process at least requires 2 sets of alignment marks on opposite sides of the wafer. Split field microscope is used to make alignment easier. So, if we use split field microscope, if you have the wafer or if you have the mask, at the same time you can see both the areas, both the alignment mark at the same time you can use or see if we use split field microscope. So, that is another point that you need to remember when you are using a mask aligner. These are few commercially available mask aligner. There is a you can go to this YouTube link and look at this how it is operated, right, and then it will be easier for you to understand what is the role of mask aligner and how we can design a mask aligner. See, in this case these are the lenses for the microscope, right, split field microscope. This is the UV exposure unit, right, and this is the X, Y and theta stage, right, X, Y and theta stage. This is for the pressure for holding the wafer and exposure time, what is the power that you are applying. This electronics is right over here. This is to move manually X, Y, Z. Then in this particular case, again here what you see is you can see a mask holder, right, and you can see a wafer. So, there is a mask holder, there is a wafer, there is a split field microscope again here. So, just go through it and see it. Again you can see very clearly it is in yellow room, it is in yellow room, this is in yellow room. You see everything whenever you use it always should be operated in a yellow room. There is a display always connected with it, so that we can see the alignment. The alignment mark we have to see, we have to adjust it accordingly, right. We have to see the pattern, you can see the pattern as well. So, these are commercially available mask aligner. Now, yeah, this is a YouTube video. So, we will play each video when the time permits. So, just go through each of the video and you will understand how it is operated, right. So, we have 3 videos here for you to observe and let us play one by one all 3 videos.
This is not a matched mask and wafer, but we should at least be able to see the alignment process. I'm satisfied with the alignment, so we'll expose. Now I'll unload the wafer and run the same wafer in topside alignment mode. Do another 5-second exposure and unload. Today is April 14th, 2013, and we are looking at Class 1 Equipment's MJB4 ID number 3685, serial number 191. This machine is through the refurbishment process and ready to be locked down for shipping. But first we'll just demonstrate the operation by running a 4-inch wafer in hard contact. There's contact. Move to the alignment gap. This is not a matched mask and wafer, but we can at least demonstrate the alignment procedure. I'll move back to contact. And press alignment check. It introduces nitrogen underneath the wafer. And now we can verify that we're still satisfied with our alignment. We are, so we press expose. And it asks to double check that you want to expose. And it's ready to unload. This machine is also set up with IR capability, so we could run the same wafer with transmissive IR rather than reflected light illumination. And to demonstrate that, we'll go to parameters, switch to IR, load. to expose, confirm. And it performs a 5-second exposure. We're ready to unload.
Okay. Now, since we know what a mass calendar looks like, what are the designs, right? There is a split field microscopy, there is a UV exposure system, and there is a mask holder, and there is a wafer holder, and we require X-Y-Theta stage for moving it. So, we can design the mask aligner accordingly, right. So, this is our design, and this is what we are working on to make a mask aligner which is cheaper, and that can go and we can use it in most of our laboratories or most of our universities, because this would be affordable mask aligner. Now, to make it affordable, first we are in the stage of designing it, and we are stage of fabricating it. So, I will show you few of the assembly that we have designed, and then a video where how it is working. For the mask aligners, the major parts of the design mask aligners are X, Y, theta stage with a wafer holder. We have a mask holder, we have a camera assembly, and we have exposure system, which is UV exposure system, right. So, for X, Y, theta for moving the wafer, and it is attached with a wafer holder, so that we can move the wafer in X, Y, and theta. We have a mask holder to hold the mask, camera assembly to look at the alignment marks, UV exposure system to expose the wafer. So, if I want to design this X, Y, theta stage, right, this is a 3D model, right, using SolidWorks you can design, using Pro E you can design, right, and this is actual model, this is actually fabricated X, Y, theta stage. There is a Z stage as well with a wafer holding module. So, we have now designed this X, Y, theta stage. So, you guys have to understand that using knowledge of 3D printing, knowledge of workshop, right. We all go to we have a course of attending a engineering workshop, right, which we understand the design, we understand how the workshop technologies can be used. So, you can use basic workshop technologies and you can fabricate this kind of setup. Little bit of understanding about electronic modules and motors and drivers is required to further operate the system. Okay. So, we have this wafer holding system. Here you can hold the wafer and you have to connect it to a vacuum system, so that you can hold the wafer correctly, and when it is it will not move. Then we have also designed a camera assembly. What we require? Camera, right? Camera to do what? Camera to understand the design, to look at the pattern on the wafer and to align it. So, camera assembly consists of a movable sub assembly system. This can be moved, right, and a camera rests on a holder. the holder can move in x direction. So, that camera with lens can focus at different points, and it will move in this direction or it can move in this direction or two holders separately. This movement is constrained, allowing only to use mask with a dimension 2 of 3 inch to 5 inch. So, we cannot use a mask which are bigger than 5 inch and or smaller than 3 inch. The movement of this subassembly in z direction allows user to focus the alignment mask properly, right. So, if you see the camera lens holder, right, this is how the lens holder looks like in an actual system. You can see here, this is a fabricated camera lens holder, fabricated module, and this is a design module. So, from design to fabrication you can do it in your laboratory, in your college. This can be a project, mini projects, right. Then we have a mask holder. So, mask holder, again you have to hold the mask. So, you have to create these holes for vacuum, so that the mask can be holded perfectly. This is a design mask holder of 5 inch, right. Left side is design and right side is the fabricated version. The mask holder slide inside the mask support. So, to support this mask holder we have to insert in the mask holder slide. The mask holder consists of two basic parts, as you can see, mask holder and mask support, right. Now, this is what we are showing is similar kind of technology is used in actually available mask aligner, right. Of course, with a little bit advanced version, but the idea is same, So, it is very important, if you see this you will understand what they have used in their particular system. So, the mask holder consists of mask basic parts, one is mask holder, second is mask support. Mask support is designed in such a way that it can house a mask with maximum dimension of 5 inch. Second is mask plates of various types can be used by using mask holders of different dimensions. Third one is the mask support can slide inside the mask holder and mask can be held within the mask holder by vacuum, right. So, this is about the mask holder. Now, if we go further, there is a wafer holder. Once we have a mask holder, we also require a wafer holder. Now, how does exactly wafer holder works? Wafer holder is designed to house the wafer on it, right. So, here you see here again we have to create a vacuum, so that the wafer can be holded. This is a wafer holder of 5 inch designed and fabricated. Actually, the wafer holder we have wafer for 4 inch, right, but the mask is of 5 inch. So, it is designed to hold wafers with minimum dimension of 2 inch and 4 inch. The holder can be 5 inch, but the mask that we can load a maximum is 4 inch. Okay. So, it can hold 2 inch and 4 inch wafer. The wafer which will be attached to the wafer holder by vacuum. Continuous suction will be provided by a vacuum pump. So, you have to connect a vacuum pump here, right, wafer holder with vacuum connector, you can see here, and this needs to be connected to a vacuum pump. So, to get enough vacuum to hold the wafer, it should not be such that the wafer will get crack or break. Okay. There is another thing that is very important, that when we design the wafer holder. Now, when you talk about the mask alignment system, what you see, you have to have a simultaneous image acquisition from two cameras, right, simultaneous acquisition of images from two cameras. Then we should have a live video display, and we should have a capability of capturing image of the alignment mark. Then we should have a joystick to control the motion of mechanical stage, and we should have the we have to align the alignment marks of wafer and mask. Right. These are the requirements for the mask alignment system, right, more or less of a mask alignment system. So, if we can address all these three requirements, we can design the mask alignment system. So, how we can design this mask alignment system and how we can interface this to a actual display, and then what kind of UV source we can design, so that we will talk in the next module. For this module, you understand that the mask alignment system or the mask aligner is a very important part of a photolithography system, and we are learning how to quickly design a mask aligner, or I am showing it to you how the mask aligner can be designed, right. So, in the next module we will see the next portion of the mask aligner and see how it can be used in actual scenario. Till then, you take care, look at the module. I will see you in the next class. Bye.